Some of the most fascinating machines in the world aren't found in giant factories. They're tucked away in small workshops, garages, and home studios. These are the machines most people never hear about. Yet, each one quietly performs an impressive job. Today, we're exploring 13 of them. From compact foods to tiny industrial tools, these devices reveal mechanical systems that turn simple materials into finished products. Small rice mill. A small rice mill is built to remove the outer husk and bran layers from rice grains using a compact streamline process. It typically includes a hopper, a husking chamber, a separating chamber, and an outlet for cleaned rice. Once the paddy rice enters the hopper, the machine uses rollers or abrasive surfaces to loosen and remove the husk. Airflow systems then separate the lighter holes from the heavier grains. Inside the milling chamber, friction polishes the rice to create the familiar white grains used in cooking. Compact versions are designed for home kitchens, rural households, or small shops, offering a close view of how rice transforms from rough harvest to clean kernels. The adjustable settings allow the operator to control polishing levels depending on preference. Some small mills also include grading screens that help separate broken grains from whole ones. The entire process demonstrates how a centuries-old manual task has been simplified into a controlled mechanical sequence. With minimal input, the machine produces uniform rice while keeping the workspace clean and manageable. Yarn winding filter making machine. This machine winds yarn into consistent layers to create cylindrical filter structures used in water filtration, air purification, or industrial cleaning systems. It begins with a central core, often made of metal or reinforced plastic. The machine winds yarn around this core using controlled tension and even rotation. A guiding arm moves back and forth to distribute the yarn evenly, preventing overlaps or gaps. Compact models rely on programmable settings that let users adjust winding speed, density, and layer count. As the machine winds the yarn tighter, it forms a filter surface with specific porosity levels depending on the intended use. This method replaces manual winding, which can be inconsistent and time-consuming. By letting the machine handle the tension and alignment, each filter emerges with predictable structure and airflow behavior. It highlights how simple materials like yarn can be transformed into functional components using steady mechanical motion. Filter core making machine. This machine forms the inner cores of filters by shaping layers of paper, fiber, or synthetic sheets around a rotating mandrel. It often includes glue coating rollers, pressure wheels, and cutting tools that work together to create tightly bonded cylindrical cores. The operator loads strips of filter media into the machine, and as they pass through the adhesive rollers, they begin wrapping around the mandrel. Pressure wheels push the layers down to remove air pockets and ensure proper bonding. Once the desired thickness is reached, rotating blades cut the core cleanly at precise lengths. Compact core makers allow users to adjust thickness, glue distribution, and diameter. These cores later become part of filters used in engines, water purifiers, industrial fans, and HVAC systems. Observing this machine in action shows how layered materials combine into rigid, durable structures capable of handling high airflow or pressure demands. It offers a clear look at how filter components are built before final assembly. Micro lathe machine. A micro lathe is a small-scale version of the traditional lathe used for shaping materials like metal, plastic, or wood. It features a rotating spindle, a cutting tool mounted on a tool post, and adjustable speed settings. The operator clamps a small workpiece into the spindle, and as it rotates, the cutting tool stems material to achieve a desired shape. Micro lathes excel in crafting detailed parts such as miniature shafts, screws, rings, spacers, and hobby components. The compact size makes it manageable on a tabletop while still offering precision. Operators can adjust tool angles, feed rates, and spindle speeds to create smooth surfaces or detailed contours. For people who enjoy machining or small prototype work, a micro lathe demonstrates how controlled rotation and cutting can transform solid material into precise geometric forms. Even though it's small, the machine operates just like full-size lathes, offering insight into turning, facing, threading, and shaping techniques. Laser Stamp Engraving Machine. This machine engraves detailed designs onto rubber, acrylic, wood, and other materials to create custom stamps or small personalized items. It uses a focused laser beam controlled by a digital interface. The operator uploads a design, adjusts power levels, and positions the material on the work surface. When activated, the laser head moves precisely along the programmed pattern, vaporizing material layer by layer. The result is a clean, sharp engraving that can capture intricate lines, logos, and text. Many versions are designed to be lightweight and compact, fitting comfortably on a desk. They include ventilation ports, adjustable focus settings, and safety shields. The final engraved rubber can be mounted onto stamp bases for use in crafting, packaging, office work, or branding. Watching the laser follow detailed patterns demonstrates how digital instructions translate into physical etching. The machine offers a close look at the relationship between laser energy, speed, and material response. Air cushion machine. An air cushion machine creates inflated packing cushions from rolls of plastic film. The film passes through a sealing element that shapes small pockets, and a built-in pump inflates them before sealing the edges. These air cushions are widely used for packaging fragile items. A compact air cushion machine allows operators to produce on-demand packaging rather than relying on pre-made bags. The operator loads a roll of compatible film, sets the inflation level, and starts the automatic feed. As the film unwinds, each section inflates and seals to form a continuous chain of protective pillows. These cushions can be torn apart at perforated sections for individual use. The controlled airflow and sealing temperatures ensure durability and consistency. The machine illustrates how simple materials can be turned into effective protective packaging through heat, air, and modular sealing. Dumpling making machine. A dumpling making machine automates the process of shaping dough and filling it with meat, vegetables, or sweet mixtures. The dough sheet feeds through rollers to create a uniform thickness. Meanwhile, the filling enters a dispensing chamber that releases measured portions into the dough. The forming molds then fold and crimp the dumplings with consistent edges. Compact models allow adjustments for size, thickness, and filling volume. By maintaining even pressure and timing, the machine produces dumplings with uniform shapes and sealed edges, reducing the chance of breaking during cooking. The rhythmic movement of the forming wheels and filling system makes the process easy to observe. It reveals how traditional foods can be prepared using organized mechanical motions. Pellet feed machine. This machine compresses powdered feed materials into uniform pellets for animals. It uses a rotating die plate with holes and a set of roller wheels that force the feed mixture through the openings. As the material exits the die, it forms cylindrical pellets that are cut to length by rotating blades. The operator mixes feed components such as grains, grasses, or supplements, then loads them into the hopper. Heat and pressure inside the machine help bind the pellets together naturally. Compact pellet machines are popular for controlled feed production, allowing adjustments for pellet diameter and density. The clear mechanical action shows how loose materials become structured. Solid pellets suitable for storage and transport. Cold oil press machine. This machine extracts oil from seeds, nuts, and other plant materials using mechanical pressure without applying high heat. It includes a hopper, a screw shaft, and a pressing chamber. As seeds enter the chamber, the screw rotates and compresses them against the narrowing outlet. Oil flows out through small gaps while the remaining seed cake exits the end. Compact versions are designed for small kitchens or workshops and allow users to observe how mechanical force separates oil from solids. Different seeds such as sesame, peanut, sunflower, or flax produce oils with unique textures and colors. Cold pressing helps maintain the natural characteristics of the oil by avoiding high temperatures. The machine demonstrates how raw ingredients transform into clean, usable oil through steady pressure alone. Soap making machine. A soap making machine blends oils, lye, fragrances, and additives into a uniform mixture before shaping it into bars. It usually includes a mixing vat, heating elements, and extrusion or molding systems. The operator adds ingredients into the vat where they combine to form soap paste. The mixture then passes through an extruder that forms a continuous bar, which is cut into individual pieces by a rotating blade. Compact machines can emboss logos, add patterns, or create different bar sizes. This process shows how chemistry and mechanical operations merge to create a consistent product from liquid and solid components. Mini cake making machine. This machine bakes small cakes automatically using a controlled heating chamber and rotating molds. The operator pours batter into the molds and the machine rotates them through zones of heat to ensure even cooking. Compact units often include automatic mold flipping or timing features that prevent burning. Once the cakes finish baking, they slide onto a cooling tray. The even movement and consistent temperature create uniform shapes and textures. Observing this machine reveals how commercial cake production can be scaled down into a manageable process suitable for small settings. Plush toy stuffing machine. A plush toy stuffing machine fills soft toys with fiber filling through an air-assisted system. It includes a motorized blower, a filling tube, and a chamber holding polyester fiber. When activated, the blower forces the fiber through the tube into the toy shell. The operator controls the amount of stuffing by adjusting airflow or timing. Compact models can sit on a table, making them suitable for small workshops or craft rooms. The transparent chamber allows users to see how the fiber moves and expands. The process demonstrates how soft toys achieve their shape and firmness through controlled filling pressure. Polyurethane foam spray machine. This machine mixes two chemical components, usually labeled A and B, to create expanding polyurethane foam used for insulation, crafting, or mold filling. The machine includes separate tanks, heated hoses, and a spray gun. When activated, it pumps the components together in precise ratios, allowing them to react and expand rapidly. The foam adheres to surfaces or fills cavities before hardening. Compact spray systems are designed for small projects and allow users to observe how controlled chemical reactions create solid foam structures. Adjusting the spray pattern and flow rate influences density and coverage. The machine highlights the interaction between temperature, pressure, and chemical blending in foam creation.